Download this code from codegive.com, link in the description below. Improving broadcast joins in Apache Spark SQL. Broadcast joins are a powerful optimization technique in Apache Spark that can significantly improve the performance of join operations, particularly when one of the datasets is small enough to fit in memory. By broadcasting the smaller dataset to all the nodes in the cluster, Spark can avoid shuffling the larger dataset, which can be expensive in terms of time and resources. When to use broadcast joins. When one of the datasets is small enough to fit in memory, typically less than 10 megabytes, but this can vary based on your cluster configuration. When you want to minimize the amount of data shuffled across the network during join operations. How to enable broadcast joins. You can enable broadcast joins in Spark SQL using the following methods. 1. Using the broadcast function, you can explicitly broadcast a data frame using the broadcast function from the org.apache.spark.sql.functions package. 2. Using SQL configuration, you can configure Spark to automatically broadcast small tables by setting the spark.sql.auto-broadcast-join threshold parameter. Example code. Below is an example demonstrating how to improve broadcast joins in Apache Spark SQL. 1. Set up Spark environment. Make sure you have Spark installed and set up. You can use PySpark for this example. 2. Create sample data frames. Here, we create 2 sample data frames, a large data frame and a small data frame. 3. Enable automatic broadcasting. You can set the spark.sql.auto-broadcast-join threshold parameter to control the size of the data frame that Spark will automatically broadcast. 4. Perform join operations. Now, you can perform the join operation. You can use either the implicit broadcast join by letting Spark handle it or explicitly using the broadcast function. 5. Show the results. Finally, you can display the results of the join operation. Performance considerations. 1. Memory usage. Ensure that the small data frame can fit into memory. If it exceeds the available memory, you may encounter out-of-memory errors. 2. Cluster configuration. The efficiency of broadcast joins can be affected by the configuration of your Spark cluster. Adjust the number of partitions and executor memory settings based on your data size and cluster resources. 3. Join type. Broadcast joins are most effective for equi-joins. For other types of joins, consider whether broadcasting is appropriate. 4. Debugging broadcast joins. You can monitor the execution plan using the explain method on a data frame to see if a broadcast join is being used. Conclusion. Broadcast joins in Apache Spark SQL can significantly enhance the performance of join operations when used correctly. By understanding when and how to use them, you can optimize your data processing workflows effectively. Always monitor your Spark application to ensure that performance remains optimal.